So another example of calculating an improper integral. Right, so in this example, we're calculating the integral from 0 to 1 of ln x. Right, and note that this is an improper integral because ln x is discontinuous at 0. Right, so first step is that you have to express your improper integral as a limit. Right, so it's a limit as t goes to 0 from the positive side, right, because the discontinuity sits at 0. Right, and then it's the integral from t to 1 ln x dx. Right, and now we have to find the antiderivative. Now, to find the antiderivative of ln x, right, that's just an integration by parts problem. Right, so let's see. That antiderivative will be x ln x minus x, right? And substituting in the bounds, right, we're going to get minus 1 minus t ln t plus t. Right. So now let's see. Well, minus 1 just stays minus 1 as t goes to 0. T goes to 0 as t goes to 0. And then what about this term here? Right, this t ln t. Right, t goes to 0, ln t goes to minus infinity. Right, so remember, this does not mean necessarily that t ln t is either going to go to 0 or to infinity. Right. It may happen that in some cases it goes to 0 and in some cases it goes to infinity. But we have to do the calculation first. We can't just say that's going to happen. Right. So, k is now equal to minus 1 minus limit t goes to 0 from the positive side t ln t. Right. So, what happens to t ln t? Well, let's make the calculation. Right, what we want to do here is to use L'Hopital's rule. Right, now L'Hopital's rule applies to cases where you have 0 over 0 or infinity over infinity. Right, so let's write our integral in that form. Right. So this becomes limit t goes to 0 of ln t over 1 over t. Right. Ln t is going to go to infinity, 1 over t is going to go to infinity. Well, ln t goes to minus infinity. Okay. And now we apply L'Hopital's rule. So we differentiate the numerator, and we differentiate the divisor, and we take the limit again. Okay, so differentiating the numerator, that gives us 1 over t, and differentiating the divider, right, and the divider is 1 over t, so differentiating that gives you minus 1 over t squared. And just simplifying a little, you get limit of minus t, which is of course 0. Okay. So what we've shown is that this term, t ln t, the one that gives us problems, goes to 0 as t goes to 0. Okay. So, and the whole thing will go to minus 1. So our integral is minus 1, okay, because it's minus 1 minus this limit. This thing is 0. Right. Integral is convergent. Yeah. So again, going over what we've done, we recognize this as an improper integral because the function we're integrating has a discontinuity at 0. And so we have to express the integral as a limit. Right? So we calculate this definite integral, and now we take the limit. And the place you have to be really careful is here. Right. T goes to 0 and then t goes to minus infinity. Right. So whenever you have something like that, 0 times infinity, infinity over infinity, or infinity minus infinity, right, then you have to be careful calculating that limit. And in this case, we used L'Hopital's rule to calculate the limit. Right.